In this video, we're going to use Minitab 19 to test a hypothesis about a mean. We're going to do this homework problem as an example. It says, suppose the mean height of women aged 20 years or older in a certain country is 62.2 inches. 100 randomly selected women in a certain city had a mean height of 62.9 inches. At the 5% significance level, do the data provide sufficient evidence to conclude that the mean height of women in the city differs from the national mean? Assume that the population standard deviation of the heights of women in the city is 4.4 inches. So first we're going to set up our hypotheses. Our question that we're asking is the mean height of women in the city different from the national mean? So that means that our alternative hypothesis is that the mean height of women in the city is different from the national mean. And different doesn't tell us a direction, whether it would be greater than or less than, so we're going to choose the not equal sign. And the national mean is 62.2 inches. So that's what I'm going to put in this, I don't know why it keeps moving, in this box. My alternative hypothesis is that the mean is not equal to 62.2. That means that my null hypothesis is that the mean is equal to 62.2. Remember that the null hypothesis is always the opposite of the alternative. So now to calculate the test statistic and the p-value, I'm going to use Minitab. So first, what we need to decide is if the problem is going to be a z problem or a t problem. Remember that we use z when we have the population standard deviation and t if we're using a sample standard deviation. It says to assume that the population standard deviation is 4.4 inches, and so that means I'm going to use z. So we're going to go to Stat, Basic Statistics, and one sample z. Now, just like with confidence intervals, we're going to change this to summarized data, enter the sample size, sample mean, and known standard deviation. So going to my problem here, my sample size is 100. We have 100 randomly selected women, and sample mean is 62.9. And known standard deviation, 4.4. Now, unlike with confidence intervals, since I'm doing a hypothesis test, I need to check the box that says Perform Hypothesis Test and enter the hypothesized mean. Hypothesized mean comes from my hypothesis. So my hypothesized mean here is 62.2. So whatever number you use in your hypothesis would go in this box. Now I'm going to click on Options. And this time I need to change what's in this alternative hypothesis box. I need it to match my hypothesis. Well, in this case, I don't need to change it because it already does match. So my hypothesis, my alternative hypothesis, is that the mean is not equal to 62.2. So that's what I want to have in this box. Mean is not equal to the hypothesized mean. If I had a greater than or a less than sign there, I would change to one of these other two options. So now I can click OK and click OK again. And then I see my confidence interval here at the top. I don't need that this time. I need to go down to the hypothesis test. And so I will see my null and alternative hypotheses here. Minitab is using H1 for the alternative hypothesis instead of HA. That's the same thing. But I see my z-value and my p-value. So those are what I need to enter into the homework problem. Z-value of 1.59. And the p-value is 0.112. Now it says to round to 4 decimal places, so I need to get some more decimal places here. 1116. So, what is this telling us about the situation? Well, remember we are comparing our p-value to our alpha, or our significance level in the problem. This is asking for a 5% significance level. If the p-value is greater than alpha, then that means that we cannot reject the null hypothesis. We need the p-value to be less than alpha in order to reject the null hypothesis. So we are not rejecting the null hypothesis. And since we are not rejecting the null hypothesis, this means that we do not have evidence to conclude that the average height of women in the city is different from the average height of women in the country.